We were bought by a company called Lithium, so we're now known as Lithium Klout. I'm also the product manager for all of our relevance and data science teams. And I'm generally going to talk about how we use machine learning and also NLP processing to do things. And one of those things is that Klout score that doesn't have any context. So let's reintroduce myself again. I'm Tyler. I have the Klout score. I also have all of these topics associated with me. These topics that are associated with me, we gather through NLP and machine learning against a whole topic ontology that we have. So now we know a little bit more about me. We have some more context here. We know I might be an expert in APIs, some advertising, Klout, I should hope so. I've worked there for 4 or 5 years now. Marketing, that's something I kind of do. Social networks, good. Down as we get a little bit further, things get a little more nebulous. They sound more like interests of mine. J.R.R. Tolkien, yep. Massively multiplayer games, yep. Machine learning, yeah, it's an interest of mine. I would note I'm not an expert in machine learning. I'm not an expert in NLP, and hopefully my presentation kind of reflects that. I have kind of a product manager's view of these things, and I leave the actual data science of it to our data scientists to decide. I'm mostly known for talking about politics of APIs issues, and I promise I won't be talking about that here. So now we can add a little bit more context in there. Not only am I an expert, maybe, in APIs, I'm at least within our ranking algorithms in the top 0.1% of people talking about APIs on social networks. Other people in that top I'll get to include many people that are actually here. So is that true? Is that not? I don't know. But this is how we represent it inside of the system for users on Klout.com. So let's start with kind of the practical application that we have. Klout itself is an application that's built on top of APIs. We're built on top of social network APIs. We consume Twitter, we consume Facebook, we consume all of these other APIs. And we normalize all the information that we bring in, and we classify it. We classify each individual message. We classify it large scale. We do all sorts of different things like that. We federate people's identity across those platforms when they give us multiple identities. So we understand them and their behavior across multiple platforms. It can be people, it can be brands, it can be all sorts of different things. So we have this kind of macro understanding of the entire kind of cosmos of Twitter or Facebook. We also have this micro understanding of the individuals there, the conversations that they're having with each other or alone, and the content of those conversations, as well as the content that they're posting, so the links and things like that. But we have this unified principle, and unfortunately, my slides are a little off here, but we have this unified principle that these topics unify everything. So every profile has topics associated with it. Every piece of content we see has topics associated with it. Every tweet we see has topics associated with it. And so as we're processing these terabytes of social interactions a day, we're applying those topics to each and every piece of content. And it's done on the fly for a lot of it. It's done in nightly jobs, it's done in weekly jobs, it's done in monthly jobs. And we go back as far as Klout has gone. So for about 8 years now, we have this corpus of data that just continually renews and learns from itself as we go across. So we're using NLP to apply that to each of those posts, to all of the content that we aggregate. And it eventually aggregates to become the Klout score on every profile, the topical scores that are associated with each topic on those profiles. The what is those topics themselves, and the why is what we call topic sets, and I'll get into a little bit more about that. So not only are those topics associated with my profile, they have different contexts and different meanings. So sometimes that topic might be something like, I'm influential in APIs. At other times, that topic might be that I'm interested in APIs. And the context and the types of conversations I'm having and interactions with people dictate what the strength of that is in that context. So another thing that we're able to do with this is then look at kind of a macro level of a given topic. What are the things going on inside of that topic? And we can kind of identify, if you look in the graph at the top there, you can kind of identify over the last 90 days or so, what's the kind of tenor of conversation around that topic. So we understand 4 APIs here is what I'm still going down. There's about 6.5 thousand experts, at least on Twitter and Facebook, that we identify. And the graph at the top kind of shows the last 90 days of activity of those experts within that. And then we have listed our top experts, and I took this yesterday. So this changed pretty significantly over the last couple of weeks because we just had the API Strat conference, and when API Strat happened, which is that big spike on the right there, this list changed considerably. Programmable web is pretty obvious, like they get a lot of retweets, a lot of mentions and things, but Ken was down, I think, somewhere at like 10 or 11 before API Strat, and he jumped up somewhere after there into number 2. Mike's pretty obvious there, and if we go through the rest of the list, if I was showing the whole thing here, we'd be pretty familiar with all of the names there, and it would make sense, I would say. So we do this time series slicing of all that data, we aggregate it all together, and we slice different sets to create these ordered lists. So there's some building blocks that go into exactly how we come to all of this. First of all, we're dealing with just ridiculous amounts of data. It's terabytes of data every day. There's 650 million new pieces of data each day, so those would be like the tweets, the various Facebook posts, everything that we end up collecting. It might even be more than that on any given day. With hundreds of millions of profiles. We have 600 million plus profiles we've identified. On Twitter alone, there's 200 million plus. For the unified profiles that have multiple identities on them, there's about 6 million plus. The insignificant number in that way, but we learn certain things from that when that happens. We currently have 10,000 topics in a 3-level hierarchy. We've actually whittled that down from 100,000 topics like 3 years ago, and we've had a more highly curated list where we combine different topics together and built a system that I'll talk about in a little bit called Webster that allows us to index different concepts into one topic and relate those topics to other topics within that hierarchy. And we update all of this on a daily basis. So for every user, their score in any given topic and topic set is updated each day. The list of topics for them is updated each day. We evaluate each day new upcoming topics that we might need to create a new topic ontology or a new entry in the topic ontology for. We have a 3-level hierarchy of this. We have super topics at the top. There's about 15 of those right now. No person actually belongs to a super topic. Everyone always belongs to either subtopics or entity topics. Entity topics are, the bread and butter things. They're the things that you would most likely recognize. They're, specific brands maybe. They're specific products. Very specific concepts, and then the subtopics are a little bit more broad. So if you follow down the main one here, we've got food and drink in a super topic. Below that we might have baking, beer, and food, and below that we have anchor steam, PBR, and pizza. And that kind of demonstrates that there's multiple, under beer, there's multiple types of entities. There's kind of related non-local entities, and then there's things that are specific products in there. And we collect from those multiple social networks. We also look at things like Wikipedia and across all the links that are ever posted on social to kind of understand the topics that are outside of the broader universe of just what's happening on social. And we have dedicated people that manage that ontology every day, edit it, go through everything. So some of the things we end up having to do is we weight it. The signals themselves, there's going into any particular topic set, there's at least 200 features that we look at. We categorize them things like 90-day features, 7-day features, 1-day features, even some hourly features. They all have different weights and work against each other, and in the different contexts of topics that we have, they all work slightly differently. We use machine learning to change that weighting, to train the data sets on it based on what we've seen in the past. And based off of survey data, so we use crowdsourced sort of survey stuff to figure out how well our topic assignment is and then train against that. But then we also use kind of a more natural way of just looking at social media and picking out the things we obviously know are true and then training against that there. So the things we're really concerned about is like which network that action is taking place. We have different weights for different networks because different networks behave differently. What type of action was being done? So is it a retweet? Is it a like? Is it a comment? Is it a share? Who it was and what kind of activity that person has and what kind of networks that they act on, because since everyone is different, the meaning of their actions might be different. And how much, so how frequently do they take actions? How frequently do they reply to people? What types of people do they reply to? And all of these things, and when, all of these things all contribute to the different ways that we weight those different things there. And so we have these ideas for topic sets, and I mentioned a little bit of this. We have users' influence, also called expertise. We have interests. We have self-selection, so those registered users tell us which topics they want associated with them. That shows interest, but it also shows aspiration, and so we treat those things very different. We have aggregate things that we look at that audience, and the audience of any person, and what interests do they have in aggregate, and what influence do they have in aggregate. And we score all of those things separately, and there's a few other sets, but let's just talk about these just to make things easy. So everything gets distilled where each of these has separate structures for weighting, and this is how we generally arrived at those topics that I was showing on the profile before. So some of the challenges we end up having here is the nature of looking at social data. So my favorite example is that just made some synonym roles. I love this one because it is extremely difficult to figure out what the meaning of that was unless you were actually like analyzing the picture, which we don't do yet, but we plan to do at some point. But you know, there's just all sorts of like different gotchas in this problem. The message size itself, every tweet is surrounded by tons of data. When you look at the Twitter API, you get all sorts of different information about that tweet beyond just that 140 characters that came with it. But there's the actual usable content inside of there is usually pretty small. That's why we go and look at links and look at additional things. There's a sparsity of text, so the vast majority of people that use any social network are not actually posting on it, they're just reading on it, and read actions are not very valuable, nor are you even able to really get them. Do you know that someone saw a tweet? Twitter doesn't publish that stuff out. They're getting there, but they don't really tell you the kind of dynamics of impression and understanding unless an action was taken on it. And there's tons of noise, the synonym roles thing, colloquial language, grammatical errors, sarcasm, abbreviations, all sorts of things. And so we roll up our knowledge of all of these things into the Webster tool to hopefully be able to suss out some of the stuff, but there's always going to be false positives. And when you're a user-facing company like we are, it's extremely embarrassing when you have those false positives because people feel very strongly about the association the machine gave to them. And if you're wrong about it, then they're very angry about it in some way. And as we probably all know as computer scientists, these are difficult problems, and it's just going to have to be that way. The other piece that we have is we do this every day. So every day we have to run through our entire pipeline for all of the content we collected in that day, and we have to do the topics assignment, we have to roll it up to the users, we have to roll it up to the content. The content engine that we have actually runs on an hourly basis and sometimes even shorter than that. So we have to run all these processes very quickly, so we don't have the time really to look at it as a we can calculate this, whatever the computing power is going to take and however long that's going to take. We have to get it done each day in a certain amount of time. So we looked at various different models of how we do our NLP, and we've pretty much decided on the dictionary model, which is what we call Webster, because it has the fastest time to where we need to be. And this is the area where I remind you that I am not an expert in machine learning or an expert in NLP. I am just a product manager, so this is my representation of that. So the Webster tool is pretty awesome. This is how our kind of topics ontology manager goes through and tunes the topics based off of the things that are happening on social media at the time. So basically, you could go through this, and we're looking at Apache Spark here, and you can add different related terms that are also going to be picked up whenever we see them for Apache Spark. So you can do disambiguations, you can do hashtags that you know are related to this, you can do different terminologies, so that you could roll all of that stuff up into topic detection for that. We also have updated this now where we have different contexts for it. So if the context was topic association to content, you might use a different set of these. Whereas if it was topic association to a user, you'd use a different set of synonyms, essentially, to associate them to them. And so we leverage all of this machine learning to train new models for additional data sources. We retrain our topics calculations all the time. We predict the actionability of support. This is one of the newest things that we're doing. So we look at like Comcast, for example, and all the support requests that Comcast get. And we can essentially predict how likely it is that a support request is something that a support rep could actually act on in some way based on a lot of this sort of social analysis, the people that are involved, their history, all of those sort of things. We're predicting the virality of content, so our content discovery system actually chooses content based on its potential to be viral, based on who posted it, who else is posting it, what types of people generally read this content, and the likelihood that it's going to travel through that network in some way. We try to predict the personhood of a social media account, so we're trying to designate between a brand or a person because you want to treat them entirely different in how you would model them, and people that use our API would want to treat them differently in how they would want to look at that data. And our whole targeting system is based off of it. So how do we productize this in APIs? We essentially have APIs that let you look up by people. This is the traditional way that we do things. And you can look up by a person and get their score and get their topics. You can look at specific topic sets. So you could look up me and get my interest topics. You could look up me and get my influence topics. But you could also look at a different way of doing this and essentially look at aggregated insights about me. So if I look through me, I'll be able to see everyone that is like me and the trends of topics that go throughout those people. Similarly, you can look up by topic and get lists of people that are either influential or interested in that topic. We can also do other aggregations of that to where people interested in this topic are also interested in these topics and other kind of aggregations that we make available through that. And so the payloads end up looking something really messy that you're not going to be able to read like this. But essentially, we have the topical scores. We have the strength that we detect on it, the various entities and subtopics that those are related to, and we return all of that data there. So let's get a little practical about how we do this beyond just what Klout does. I'm looking for ways that we can grow this out. So we're looking to parameterize the way that we look things up. So some of our topical endpoints are based very definitely off of a certain topic set or a certain modeling engine that we arrived at to get to the scores that we're approaching there. So if you would think about our overall topical scores are based off of those hundreds of different features all modeled together to arrive at one score for that user for that topic. And one score does not fit all. So there's some context where you're going to want to be able to pare that down and select maybe a subset of those features to then create that score instead. So instead of looking at a 90-day window for a person, you might want to just look at a 7-day window for that person so that you can look at more for trend analysis, for emerging things, and have that score be a lot more volatile. So some examples for like how we do our content discovery system is we have a whole interchangeable rule system that anytime that we surface that content up to a user, every user has a different rule set that's assigned to them, and we can A/B test different rule sets with them. We can see how they interact with that content based off of those different rule sets. And so we have a whole bunch of statistical models of which rule sets enable certain types of behavior, and we can interchange them really quickly. So it allows us to use a different set of features, essentially, to calculate different ways to look at the content. So when you're doing this sort of stuff and you're building out these APIs, I generally recommend, yes, you can't always predict what someone's going to do, but you should at least try always to predict what someone's going to do with your API. So that might mean that you're going to build out the various possible implementations that you can do, just so you can understand where you think someone's going to go with it, so that you can, and I'm going to get to where I lied. I am going to talk about politics of APIs. You need to get to a point where you can predict essentially what they're going to be doing with your API, so that you can write a terms of service that actually accommodates that, so you can write marketing materials that accommodate that. You want to make sure that you get the best possible situation to encourage people to do everything with your APIs that is possible, but also to make sure that they aren't going to go violating your terms of service or your down-level terms of service or anything anti-competitive that you don't want to have happen. Some examples of that sort of stuff is that I think the representation of data is really hard. We represent data on Klout one particular way, and it's for consumers, and that's how we represent it. So you saw that I had the 0.1% of experts in APIs. That's one way you could represent a topical score. If you just put that raw topical score in front of people, it doesn't mean anything. So there's no reason to do that. So you might want to have a policy where you say you just can't use that score for direct representation to consumers. You have to do something with it. You might want to divide it into quartiles. You might want to show it in a graph, but you can't just show people that score. And thinking about things like that is one way that you can protect your API, but also encourage innovation, because then if you tell them one thing they can't do, then they can think about all the things they can do with it. And so lastly, we have some research papers available. The whole data science team works on the KDD Summit. And the most recent thing that I think was published is this document. It's the LASTA, Large-Scale Topic Assignment on Multiple Social Networks. And for anyone that's interested in how we technically go about all of the topic assignment to users and to content, this it pretty much describes our approach and the mathematical models we use and everything we do there. So thank you very much.
Not a question. Is someone tired? Okay. We have a question here.
Hi there.
Hi.
Thanks for the chat. Really interesting. I was interested by your data input. You come from the US, and like the US, Barcelona as well is bilingual, Catalan and Spanish. And the US has a heavy Spanish population and probably many other languages beyond that. And I imagine on social media, people jump between languages. Something I'm interested in, how do you aggregate? I'm sure it's possible, obviously, to use NLP in different languages, but do you then aggregate scores together from different languages? How does that work?
So everywhere prior to this year and even prior to a couple months ago, we just didn't. We only saw English. We only had an English ontology. So we didn't do topical analysis for it. The Klout score itself always still represented it, because the raw actions they don't have a language. You reply, you retweet, you post things. That is all consistent. We recently just rebuilt the entire ontology to where now we have multiple ontologies that can sit on top of each other and overlay. So we can have multiple languages sit on top of each other and still relate to the same terms or same concepts, at least in a way. And we're just now starting to roll that out. So we just localized Klout.com, the site, to various different languages. So that was our first step, was to enable that piece there. And the next step over probably the next 2 months now, we're kind of training our models to make sure they're correct. But over the next couple months, we'll actually release the ability to separate out the languages into topics, so that when you refer to one topic in English, we know that that's the same topic in Spanish, and when people are talking about it in Spanish, we can map it all together.
You
I don't, but I imagine our data science team does. I can certainly put you in touch so you can ask. They love to talk about this stuff, so I mean, they'd love to have been here to talk about it.
Yeah, one question far away.
Have you thought about extracting information from pictures, video, audio, to not only from text to get this social? Because nowadays, as bandwidth is growing up, people usually put their pictures instead of rare text on the.
Definitely, it's extremely valuable for marketing because all marketers instinctually know that content with images and video travel even better. So those are things that we're always really interested in. There's a company called Ditto Labs out of Boston that is doing a lot of analysis around pictures and video and like does object detection, so they know when like a Nike shoe is inside of a picture or inside of a video and can do the topic association there. We're not doing it yet, but we plan to go in that way. My hope as a product manager is that we don't rebuild the wheel and do it all ourselves. I'd much rather leverage someone else's API that's already doing that and is an expert at it. But I also know my data scientists, and they're probably going to want to do it themselves anyway, so that we'll probably rebuild it anyway. Or I can do Watson, Andy tells me.
So it's a really good introduction for the next talk. So thank you, Tyler.
Thank you
very much.